There is a place in the California desert where the sun does not simply shine. It burns. It presses down on the land with a kind of ancient authority, as if it has been doing this for millions of years and intends to keep doing it forever. That place is Palm Springs, and most people who visit think they understand it. They see the palm trees lining the boulevards. They see the turquoise swimming pools shimmering behind white walls. They see the Art Deco hotels and the celebrity homes and the golf courses stretching out toward distant mountains. They think Palm Springs is a resort town, a playground, a place where the wealthy come to rest and be seen. But underneath all of that, underneath the glamour and the glitter and the carefully maintained image, there is something much older, much stranger, much more powerful. There is stone, ancient stone, stone that has been here since before human beings walked the earth, stone that holds secrets older than memory, stone that shaped this valley long before the first person ever laid eyes on it. This is the story of that stone. This is the story of what it tells us about time and nature and the hidden life of the desert. This is the story of the geological soul of Palm Springs. To understand Palm Springs, you must first understand where it sits. The Coachella Valley is a long narrow depression in the earth, stretching roughly from the San Gorgonio Pass in the northwest to the Salton Sea in the southeast. It is bounded on the north by the San Bernardino Mountains and on the south by the Santa Rosa and San Nicanso Mountains. The valley floor sits at roughly 250 feet below sea level in some places, making it one of the lower points in North America. But the mountains that surround it rise to staggering heights. San Jacinto Peak, which looms directly over the city of Palm Springs, soars to 10,800 feet above sea level. That means the vertical relief from the valley floor to the mountain top is nearly 11,000 feet. That is one of the steepest escarpments anywhere on the surface of the earth. Standing in downtown Palm Springs and looking up at San Jacinto is not simply a scenic experience. It is a confrontation with geology. You are looking at billions of years of Earth history stacked up in one dramatic wall of rock. And that wall of rock is trying to tell you something if only you would listen. The rock of the San Jacinto Mountains is predominantly granite, but not just any granite. This is peninsular ranges batholith granite, a vast mass of igneous rock that was formed deep beneath the surface of the earth between roughly 180 million and 80 million years ago. Back then, this region was not a desert. It was not even dry land. It was the age of a continent slowly being reshaped by the collision of tectonic plates. Magma rose from deep within the earth and cooled slowly far below the surface, forming the crystalline interlocking mineral structure that we call granite. Over tens of millions of years, the overlying rock was stripped away by erosion and the granite was exposed at the surface. What you see today on the face of San Jacinto is rock that spent most of its existence deep inside the earth, rock that has been traveling upward for millions of years, rock that is still moving upward even now, even as you watch it, even as you take your morning hike or sip your coffee on a hotel terrace overlooking the valley. The mountain is still rising, slowly, imperceptibly, but rising nonetheless. The reason the mountain is rising has everything to do with the most important geological feature of the Palm Springs region, the San Andreas Fault. The San Andreas Fault is one of the most famous geological structures in the world. It is a transform fault, a place where two massive tectonic plates grind past each other, not crashing head-on but sliding laterally. The Pacific plate to the west moving slowly northward, the North American plate to the east holding relatively still. The boundary between these two plates runs directly through the Coachella Valley. It passes just to the east of Palm Springs beneath the valley floor, and it is the engine that drives everything that happens here geologically. The fault is not just a crack in the ground, it is a zone of immense complexity, a region of fractured and pulverized rock, dozens of miles wide in places, a place where the earth is perpetually stressed, perpetually strained, perpetually on the verge of sudden violent readjustment. Every earthquake that rattles the windows of Palm Springs is the sound of that readjustment happening. Every tremor is a reminder that the ground beneath this resort town is anything but stable. But the San Andreas Fault does more than shake the ground. It shapes the landscape in profound and lasting ways. The abrupt rise of the San Jacinto Mountains directly next to the flat valley floor is not a coincidence, it is a direct consequence of faulting. As the plates grind past each other, the rock on one side is lifted while the rock on the other side drops. The mountains go up, the valley goes down. Over millions of years, this differential motion creates exactly the kind of dramatic topography that characterizes the Palm Springs region. The steep faults curve on the western edge of the valley, the alluvial fans spreading out from the mouths of mountain canyons. The bajaras, those gently sloping surfaces of accumulated debris that form the transition zone between mountain and valley floor. All of these features are written in the language of tectonics. All of them are expressions of the same fundamental force, the grinding of the plates. Now let us talk about the rocks themselves. The rocks that you can actually see and touch. The rocks that hikers encounter on the trails above Palm Springs. The rocks that line the desert washes and tumble down from the cliffs. These rocks are not passive objects. They are active participants in the ongoing story of the landscape. And they carry within them a record of everything that has happened here. Everything that the landscape has experienced, all the way back to its beginnings. The granite of the San Jacinto Mountains is composed primarily of three minerals: quartz, feldspar, and mica. You can see all three if you look closely at a piece of granite from the hills above Palm Springs. The quartz shows up as glassy gray or translucent grains. The feldspar appears as white or pinkish crystals, and the mica glitters in the sunlight as tiny metallic flakes of silver or gold. These minerals crystallize from molten rock deep in the earth, and the size of the crystals tells you something about how slowly the rock cooled. Large crystals mean slow cooling. Small crystals mean fast cooling. The coarse-grained granite of the San Jacinto Mountains cooled very slowly over millions of years, which means it spent a long time deep underground, in a place of intense pressure and heat. A place utterly unlike the bright open desert where it now sits exposed to the sun and the wind and the rain. The transition from deep underground to exposed surface is a journey of transformation for rock. As granite rises toward the surface and the pressure of overlying rock decreases, it begins to expand. The expansion creates stress within the rock mass, and that stress is released through fracturing. The rock splits along curved parallel surfaces in a process called exfoliation or spalling. The result is the rounded dome-like outcrops that you see throughout the desert landscape around Palm Springs. Great smooth curved boulders stacked atop one another like enormous eggs. These forms are not random. They are the signature of a specific process, the signature of pressure release and differential weathering. The rough angular edges of a granite mass weather away faster than the interior. The rock rounds itself over time, becomes smoother, more organic looking, more like something alive than something mineral. Walk into any of the canyons above Palm Springs and you will see this process at every scale. Individual boulders rounded and smooth on their upper surfaces. Outcrops shaped like breaking waves. Entire hillsides covered in a jumble of rounded rock forms that look almost architectural. Almost as if some giant hand arranged them deliberately. But there was no hand. There was only time and water and temperature and chemistry working together in the slow, patient way that geology always works. The boulders did not arrive there from somewhere else. They grew out of the bedrock beneath them. They are the bedrock, shaped by millions of years of weathering into the forms you see today. Water is perhaps the most powerful sculptor of the desert landscape, despite what most people assume. They see a dry, hot environment and they think water has nothing to do with it. But water is everywhere in the geology of Palm Springs, even when you cannot see it. It flows underground through the fractured granite. It seeps along fault zones. It collects in the pore spaces of sedimentary layers. It feeds the springs that gave Palm Springs its name. And periodically, during intense storms or seasonal snowmelt events, it rushes down from the mountains in powerful torrents that reshape the landscape in hours. The alluvial fans that spread from the canyon mouths across the valley floor were built by water. Each flood event adds another thin layer of sediment, another increment of material transported from the mountains to the valley. Over thousands of years, these increments add up to features that are miles across and hundreds of feet thick. The ground you drive across on your way into Palm Springs, the ground beneath the parking lots and the golf courses and the hotel lobbies, is a thick accumulation of material carried down from the mountains by water. Desert water, intermittent and violent and endlessly creative, this spring in Palm Springs that the Cahuilla people have known about for thousands of years. It emerges from the ground at the base of the mountain near what is now the Indian Canyons area. The water that feeds the spring fell as rain or snow on the high slopes of San Jacinto thousands of feet above. It percolated down through fractures in the granite, moving slowly through the rock for years or decades before emerging at the surface here in the valley. The spring is a geological feature, a consequence of the structure of the rock and the orientation of the fault zones and the topography of the landscape. But it is also the reason human beings came here, the reason the Cahuilla chose this valley as their home, the reason Palm Springs exists as a place of human habitation at all. The stone made the water, and the water made everything else. The Cahuilla people have a relationship with the geology of this valley that is deeper and older than anything a geologist with a degree and a rock hammer can claim. They have been here for at least 2000 years and possibly much longer. Long enough to have witnessed the landscape changing, long enough to have integrated the rocks and the springs and the mountains into their cosmology. Their traditional territory encompasses the entire Coachella Valley and extends into the mountains above it. The canyons that cut through the Santa Rosa and San Jacinto mountains are sacred to them, places where the physical world and the spiritual world interact. And it is not hard to understand why. When you stand in one of those canyons and feel the weight of the rock walls rising on either side of you, the silence is not empty. It is full of time, full of the accumulated presence of a landscape that has been here for unimaginable spans of time. Palm Canyon is perhaps the most dramatic of these sacred canyons. It is one of the longest native palm oases in the world. The California fan palms that fill the canyon floor are not planted, they are wild. They grow here because water is available, because the fault that runs along the canyon floor brings water to the surface. The palms are biological markers of a geological feature. They are growing along a fault line. They are rooted in the fracture zone where rock has been broken and water flows. Stand in Palm Canyon and look up at the granite walls rising on either side. You are standing in a crack in the earth, a crack that was made by the same forces that made the San Andreas Fault, the same forces that are still active today. The ponds are beautiful, but are beautiful because of geology. The rocks in Palm Canyon tell a story of enormous violence followed by enormous patience. The canyon walls show clear evidence of faulting. Zones of crushed and altered rock called fault gouge, slick insides which are polished and straight surfaces created when rock masses grind against each other. Beams of quartz and calcite that crystallized from hot fluids moving through fractures in the rock. Each of these features is a record of an event, a moment in the long history of the canyon when something happened, when forces exceeded the strength of the rock and the rock gave way. And then the patient work of erosion began, water moving through the fracture zone, widening it, deepening it, carrying the broken rock downstream over thousands of years, creating the canyon that now shelters the palms and the creek and the hiking trails, and the people who come here to find something they cannot quite name, but can feel in the presence of ancient stone. Let us go further back now. Further back than the granite, further back than the tectonic plates. To understand the deepest secrets of the stone in Palm Springs, we need to go back to a time when this part of North America looked nothing like it does today. 4 indeed million years ago, this region was covered by a shallow tropical sea. Coral reefs grew here. Trilobites and brachiopods and crinoids lived in the warm, clear water. Sediments accumulated on the seafloor, layer by layer, year by year, century by century. Those sediments eventually became sedimentary rock. Limestone and shale and sandstone, rocks that still exist in this region today, although they have been transformed almost beyond recognition by the heat and pressure of the burial and by the intrusion of the granite magma that rose beneath them. The metamorphic rocks that you sometimes see in the hills around Palm Springs are the ancient sediments, cooked and recrystallized by geological heat. transformed from their original layered forms into contorted and banded masses of marble and schist. They are the oldest rocks in the region, the foundation upon which everything else was built, and they represent a time so different from the present that it requires a genuine act of imagination to comprehend it. Imagine standing on this spot 400 million years ago. You would be underwater. The sky above the water surface would contain an atmosphere with different proportions of gases than the air you breathe now. The continents would be arranged in completely different configurations. North America as a recognizable landmass did not yet exist. The creatures swimming around you would be utterly alien. No fish that you would recognize, no mammals, no reptiles, no birds. Nothing that looks familiar except perhaps the basic shapes of shells and worms and algae. And yet the calcium carbonate that those ancient creatures deposited when they built their shells is still here, still present in the rocks of the Palm Springs region, still telling the story of that ancient sea to anyone who knows how to read it. Geology is the science of deep time, and deep time is something that the human mind struggles to grasp. We can say the words, we can recite the numbers. 100 million years, 400 million years, 4 billion years. But we cannot feel those spans of time the way we feel a passage of an hour or a year or a lifetime. The stone in the mountains above Palm Springs is a kind of bridge between human time and geological time. When you touch a boulder of San Jacinto granite, you are touching something that has existed for 100 million years. When you run your hand along a vein of quartz in a canyon wall, you are touching minerals that crystallized from superheated water millions of years before the first human being ever walked the earth. The stone does not care about human time. The stone is operating on a completely different scale. And there is something both humbling and strangely comforting about that. The desert environment of Palm Springs is itself a geological phenomenon. The aridity of the Coachella Valley is not simply a matter of low rainfall. It is a consequence of topography. The San Bernardino and San Jacinto mountains create terrain shadow effect. Moist air moving inland from the Pacific rises over the mountains. As it rises, it cools and the moisture condenses and falls as rain or snow on the western slopes. By the time the air descends into the Coachella Valley on the eastern side of the mountains, it has lost most of its moisture. The valley receives on average less than 6 inches of rain per year. The same mountains that produce the dramatic scenery that makes Palm Springs so visually striking are also the reason the valley is so dry. The mountains make the desert, and the desert is a geological environment, an environment where the processes of weathering and erosion operate in a distinctive way, where wind becomes a major erosional agent, where chemical weathering is slower than in wetter climates, where the physical breakdown of rock dominates, where the landscape develops its characteristic forms over vast spans of time. The desert varnish that coats the rock surfaces in the Palm Springs area is one of the most striking visible features of desert geology. It is the dark brown or black coating that you see on boulders and cliff faces, that shiny dark patina that gives the desert rocks their characteristic appearance. Desert varnish is composed primarily of manganese and iron oxides. It is deposited by microorganisms, bacteria and other microbes that live on the rock surface and concentrate minerals from dust and rainwater over hundreds and thousands of years. The varnish accumulates very slowly, just a fraction of a millimeter per thousand years, which means that a thick coating of desert varnish on a boulder represents an enormous span of time. The boulder has been sitting in the same place long enough for this biological and chemical process to coat it over and over again, building up layer by layer, year by year, millennium by millennium. The Cahuilla and other indigenous peoples of the Southwest recognize the significance of desert varnish, not in geological terms but in practical and spiritual ones. Dark varnish surfaces provided a canvas for petroglyphs, images packed into the rock by removing the dark varnish to reveal the lighter rock beneath. The petroglyphs found in the Palm Springs region are among the most fascinating archaeological artifacts in the American Southwest. They are conversations with stone, messages left by people who understood that the rock could endure long after they were gone, people who chose the most permanent medium available to them. And they were right. The petroglyphs have lasted for thousands of years. The desert varnish that forms their background has been accumulating for tens of thousands of years, and the stone itself has been here for millions of years. The layers of time are nested one inside the other like Russian dolls. Human time inside geological time inside cosmological time. There is a particular kind of rock formation found in the hills above Palm Springs that deserves special attention. These are the granite tors, isolated rounded masses of rock that rise dramatically from the desert floor. They look almost like sculptures, like something that was placed there deliberately, but they formed entirely through natural processes, through the interplay of jointing and weathering and erosion. Granite is typically fractured into blocks by three sets of joints. Horizontal joints formed by pressure release as the overlying rock was removed, and two sets of vertical joints formed by the stresses within the cooling granite mass. These three sets of joints divide the granite into more or less rectangular blocks. Then chemical weathering attacks the corners and edges of these blocks more vigorously than the flat surfaces. The corners and edges have more surface area relative to their volume. They weather faster, they round off, and as the surrounding material is chipped away by erosion, the rounded cores remain, standing proud above the landscape, looking like monuments to geological time. Some of these granite tors above Palm Springs are extraordinary in their scale and their form. Great rounded masses of rock, 15 or 20 feet across, balanced on narrow bases. Boulders perched in probably atop other boulders. Rock formations that seem to defy gravity and common sense. But they do not defy gravity. They obey it completely. Every form has been shaped by the same forces, by water and temperature and chemistry work over millions of years. The apparent improbability of these forms is just a measure of our limited understanding of time. We look at a boulder perched on a narrow base and think it might fall over at any moment. But that boulder has been in that position for hundreds of thousands of years, and it might remain in that position for hundreds of thousands more. Our sense of what is stable and what is precarious is calibrated to human time scales. The desert operates on geological time scales. And on geological time scales, things that look precarious to us are actually perfectly stable. The hot springs of Palm Springs are another expression of the region's geological character. The word springs is right there in the name of the city, and those springs have been attracting visitors for a very long time. The water that emerges from the hot springs of Palm Springs has been heated by contact with hot rock deep in the earth. Along fault zones and fracture zones, water can circulate deep into the crust where temperatures are elevated. It absorbs heat from the surrounding rock and then rises back to the surface, carrying that heat with it. The temperature of the water at the surface reflects how deep it has traveled and how long it has spent in contact with hot rock. Some of the hot springs in the Palm Springs area produce water at temperatures well above 100 degrees Fahrenheit. This water has been on a journey through the deep rock, a journey that began perhaps as rainwater falling on the mountains and ended here at the surface of a desert valley after years or decades of travel through fractured stone. And the mineral content of the hot spring water also tells a story. As water moves through rock, it dissolves minerals from the rock surface. Different minerals dissolve at different rates depending on temperature and chemistry. Hot water dissolves more minerals than cold water. By analyzing the mineral content of spring water, geologists can infer something about the rock types that the water has moved through. They can trace the underground journey of the water. They can build a picture of the subsurface geology that cannot be seen directly. The hot springs of Palm Springs are windows into the underground. They are sampling points where the deep geology expresses itself at the surface, where the hidden world of rock and fracture and deep heat makes itself known to the world above. Now let us consider the broader picture, the bigger story that all of these geological features are telling. The granite and the faults and the springs and the boulders and the desert, varnish and the alluvial fans, they are all chapters in the same book, the book of a landscape that has been continuously transformed over hundreds of millions of years. A landscape that is still being transformed, still active, still evolving, still writing new chapters even as we watch. The San Andreas Fault is not finished. The mountains are not done rising. The alluvial fans are not complete. The desert varnish is still accumulating. The springs are still flowing. The granite is still weathering into new forms. Palm Springs is not a static but drop for human activity. It is a dynamic geological system operating at timescales that dwarf human history, and the stone is the record of that system. The stone remembers everything. Shh. Consider what the stone has witnessed. It has witnessed the collision of continents. It has witnessed the birth of ocean basins and the death of others. It has witnessed ice ages when glaciers crept down the slopes of San Jacinto and the desert below was cold and wet and green. It has witnessed periods of volcanic activity when the landscape was shaped by eruptions and lava flows. It has witnessed the arrival of the first human beings in this valley and all the changes they have made. The stone has been here for all of it, patient and enduring and indifferent to the brief drama of human presence. We newcomers here, we have been in this valley for a few thousand years. The stone has been here for hundreds of millions. On the scale of geological time, our entire history is barely a moment. And yet that moment matters. It matters because we are the first creatures on this planet capable of reading the story the stone tells, capable of understanding the processes that shape the landscape, capable of looking at a boulder and knowing that it spent 100 million years underground before rising to the surface, capable of recognizing in the forescarp the expression of tectonic forces operating at the scale of continents, capable of understanding that the hot spring water has traveled through deep rock and carries within it a chemical signature of their journey. We are the only creatures who can do this, who can decode the language of stone, who can listen to what the landscape is saying and understand it. That is a remarkable thing. It is a privilege that comes with a responsibility. The responsibility is to treat this landscape with the respect that its age and complexity deserve. Palm Springs and the Coachella Valley are in some ways one of the most intensively modified landscapes in the American West. The water that feeds the golf courses and the swimming pools and the hotel gardens is largely imported from distant sources. The Colorado River, the Sacramento Delta, the groundwater basins beneath the valley floor, that groundwater accumulated over thousands of years, recharged by rain and snowmelt filtering through the alluvial deposits. It is being withdrawn at rates that exceed recharge. The water table is dropping, and when groundwater is removed from the sedimentary layers that hold it, those layers can compact. The ground surface can subside. In some parts of the Coachella Valley, measurable subsidence has already been recorded. The land is sinking slowly, incrementally, but sinking. The geology is responding to human activity. The story being written in the rock today includes a chapter about us, but there is also reason for hope in the stone, because the stone tells us about resilience, about the capacity of landscapes to absorb bumps and persist. The Coachella Valley has been through ice ages and warm periods, floods and droughts, earthquakes and volcanic events, periods when the Salton Sea was vastly larger than it is today, and times when it was dry. The landscape has changed profoundly many times over. It is not fragile, it is ancient and resilient and enduring. The springs that fed the Cahuilla people for 2,000 years are still flowing. The granite mountains are still rising. The alluvial fans are still being built grain by grain with every storm event. The desert is still doing what deserts do, slowly, patiently, powerfully, on geological time scales. The secrets hidden in the stone of Palm Springs are not really secrets at all. They are stories written in a language that most people never learn to read. But they are there for anyone who takes the time to look. To really look, not at the resort amenities and the celebrity architecture and the manicured landscapes, but at the rock beneath, the fractured granite, the desert vanished boulders, the alluvial fans spreading from the canyon mouths, the fault scarps running along the base of the mountains, the hot springs rising from the deep rock. These are the real Palm Springs. The Palm Springs that existed before people arrived, and that will still exist long after people are gone. The Palm Springs that was shaped by forces so vast and so powerful that human activity seems almost inconsequential by comparison. And perhaps that is the most important thing the stone has to teach us: perspective. The stone offers a perspective on time and scale and significance that is genuinely humbling. Standing on a granite outcrop above Palm Springs and looking out over the valley, you can see the city below, the streets and the buildings and the golf courses and the pools. all of it fitting within one small corner of a vast desert landscape that stretches to the horizon in every direction, and surrounding all of it the mountains, ancient and enormous and indifferent, made of rock that has been here for 100 million years, rock that will still be here 100 million years from now, when everything that human beings have built in this valley has long since returned to dust. The stone will remember us, not because it cares, but because everything that happens here happens on an in and through the stone. We are part of the story now, a brief and vivid chapter in the long geological biography of this extraordinary place. So the desert wind moves through the canyon, the garnet shimmers in the heat, the fan palms rattle their leaves and cast moving shadows on the rock. The spring flows out of the hillside as it has flowed for thousands of years, carrying the memory of rain that fell on distant mountains, carrying the memory of deep rock, carrying the slow, steady story of a landscape that was old beyond imagination before the first human eye ever saw it. This is Palm Springs, not the resort, not the playground, not the city, but the stone, the ancient patient permanent stone that underlies everything, that holds everything up, that remembers everything. The stone secrets of Palm Springs are all around you if only you know how to look. And now perhaps you do. Shh.